Okay, so in today's concept, Deepa, we will be looking into mostly like a normal distribution. So yesterday we did see about a few of our functionalities that were required. We did see about permutations, the combinations,
Hmm.
probabilities, and then we were looking into disk plot and how we generally show things in a distribution plot. So we are
Hmm.
seeing about these, right? So today what we'll also focus on is we will look into something called as a normal distribution. So before getting on to a normal distribution, what we might have to do is we'll need to know some of the basic concepts there, like mean, median, mode, right?
Okay. Hmm.
And we'll need to see something called standard deviation, and
Okay.
we'll need something to know about variance. So let's see how are we going to understand these concepts, and then maybe if we are trying to look in for normal distribution, it will make a logical sense for us to understand these concepts better.
Okay.
Okay, so what we will do is let's take up a usual distribution. So in a usual distribution, whenever we are trying to create a particular graph or a line, whenever we are saying from a statistical perspective, what we generally do is we also consider something called how is this distribution looking, right? So usually what we will try to see from statistics perspective is whether this particular distribution is forming a bell curve or not. So
Belker is the ideal one that is expected
yes, the
instead
ideal
of flat.
scenario in which data should be there is the expectation is a bell curve, right?
Mhm.
And usually all natural phenomena that we are looking into follows a bell curve, right?
Okay.
So you either take your IQ scores,
Hmm.
right,
Survey
or
list.
heartbeats or the sugar levels or
Hmm.
your blood pressure levels and anything, right? So what happens is, how is that they are saying, okay, this is the normal level. From this to this, if it is there, this is considered as normal. And after that,
Hmm.
if it goes, it is abnormal kind of, right? So it differs from person to person, right? So how are they coming out to this normalization concept? So what they generally do is they just take randomly the heartbeat or the sugar levels of all the patients across, and then
Hmm.
they try to put it in a form of a graph like this, something very similar, right? And what they generally do is they'll try to see what is the mean of this. So mean is basically what? Taking all the pointers, dividing it by number of points. For example, if I'm taking 100 observations, so I'll take the sum of all these 100 observations and I'll be dividing it by 100,
Hmm.
right? So that basically gives me a mean. But what happens is the mean is the one which is also more prone to outliers. We are going to see about the concept called outliers, what this outlier basically means and things with some practical examples there. Okay. So for now you understand mean is something like a center point or something like a sum of all points that were
Most of
taken.
the data fits into is called mean value.
Yeah, the center point of all the data where
Hmm.
the data will be aligned closely, we can
Hmm.
call it as a mean, right? So
Okay.
there could be some data points. So let's take an example of a sugar, right? They say if your sugar levels are more than 150, 155 or 160, then this is considered as abnormal,
Okay.
right? And if it is falling within a range of 80 or 90 to 150, this is considered as normal.
Hmm.
But they also say like, okay, if it is slightly more than this, you are in a border level of the sugar. And they take a 3 month average, kind of like HbA1c, and try to say like, okay, your sugar for last 3 months has been this. And this is how generally they try to compute the sugar levels. So also if you see any organization's profitability also, if you see, when the organization is getting started, it would have started slowly, and after that it would have increased and it would have attained a peak at some point.
And then
And
drop.
that, yeah, and then after attaining its peak, it will drop little by little. And
Mm.
finally, depending on the organization's values, if they are not willing to change, kind of, or not introducing new products, kind of, then it
Mm.
will slowly decline. So this is
Okay.
what happened to very big organizations, right? If you remember, there were organizations called Kodak Camera. So there is a use
Mm-hmm.
case also for these guys.
Oh.
Not sure if you have heard about this use case. This Kodak camera, basically, these guys started really well. And
Mm.
everywhere in previous times, there used to be camera film was the only option. So these guys were a monopoly kind of in doing
Mm.
this camera films and these lenses. So though you can purchase a camera from there, I'm not sure if you have seen this, Deepa. There will be a kind of a battery kind of thing where they will be calling it as a film roll. Earlier,
Yeah,
the
I
photo
saw
would
in
have
my
been,
childhood. So they hit
yeah,
their peaks at one point and then declined completely.
yes, because what has happened is they were at their peak, right? And after
Mm.
that, they didn't innovate much. So they were like, okay, they thought like, okay, whatever they know is going to be the world view.
Same like Nokia.
Yeah, exactly. Same like Nokia, right? So
Okay.
all these things, natural phenomena, whatever you
Mm.
see there, that will be following this kind of pattern only. Right? So whatever is
Okay.
supposed to be a sales or the profitability, it might peak at some time. So just because it is peak, you cannot just loosely take that. And if you're just leaving the organization as it is and trying to see like, okay, it is going to grow the same way, that will be really foolish because
Mm.
you have to catch up with the market, right? The same thing works for our career graph also, Deepa. So there will be a certain point where our education would have helped us. So we would have slowly started from here and we would have come to the peak. And
Okay.
after coming to the peak, if we are just thinking, okay, I have attained this, so let me just be as I am, then what happens? There is a new technological innovation comes and it takes over, right? Slowly, then
Mm.
it will, if you are not going to change along with the curve, you are going to be left behind,
Left,
right?
right.
So this natural phenomena or this kind of normal distribution was invented by a German scientist. So they call him as Gaussian distribution also. It is also called as, right? So you can use this normal distribution for trying to find out any natural phenomena or any pattern of the data. Whenever you are trying to look into, you will try to see like what is the mean of this data and how far this data is distributed across.
Okay.
Okay. So, as we are seeing this normal distribution, I spoke about mean here. And also there is a concept of standard deviation there. So first I'll show you a curve, how a normal curve will generally look. Okay, so this is how a normal distribution curve will look like. Okay, let's see this. Are you able to see my screen clearly or
Mm-mm.
click on that link? Try to see what this curve is. Okay, you see here?
Means okay.
This is a bell curve these guys have given for the employee our
Okay. Okay.
appraisals, right? Appraisal cycles. So basically, here you see within this bell curve, make it slightly small so that I
Mm.
can fit in. Okay, so see this smaller. Okay, are you able to see fully?
Yeah,
Deepa?
yeah.
Okay.
Serious underperformance below expectation. Yeah, I can see.
Yes, yes, you see that. So this is what happens in our appraisal cycles also. All
Mm.
employees, they will be putting it between this category, right? So there will be one standard deviation, two standard deviation, and three standard deviations for
Mm.
any income range or any appraisals that we are currently going to put across, this
Mm.
will follow three standard deviation ranges. So that's why our rating point scale will be like 5-point scale or 6-point scale, depending on organization to organization. But
Mm.
eventually, what will happen is they will try to fit into this bell curve logic.
Okay.
So what happens here is the first range here that you see in the bell curve, which is this will be mean of your data. So the mean will be my center point. You see how much it is? The my center will be 50%. Okay.
Mm.
My center will be exactly 50%. To my
15,
left
50.
of my 50 and towards right of my 50 will be
Mm.
my first standard deviation. So this is basically the meets expectation range theta. So which is like
Okay.
mostly three or four that we give, right? So here is where 50 to 60 percentage of our entire employee base will come into. So
Mm.
they'll try to put most of them in the meets expectation range. At least like
Mm.
half of the team. If there are 10 team members, in out of 10 team members, 5 will be put in meets expectation across
Okay.
organizations. Right? So now maybe in some teams it might differ slightly, but overall when we are going to do this exercise, this should meet that criteria. Okay, so this will be
Okay.
the 50 percentage. To my left of this, which will be another 15 percentage. So this will be like below expectations. So below expectations are people who have not done a great job, or they were not able to deliver on things. They were not able to put the effort that was required by the manager or the team, and they were not
Mm.
participating in many things due to various reasons, right? So
Yes, yes.
those kind of people will be the rest of this 15 percentage.
Okay.
And there will be another range, another 10%, what you can see below that, it is like seriously below the expectation. So these are the people who will be in a PAP range, performance
Mm.
improvement program, they would have been put under already. So they are the people who are totally not doing anything, or the work, whatever they are doing is not as per the expectations of the organization.
Mm.
Right? You can see, and the same way towards the right of this, you can see till here the 50 percentage will be there, till one standard deviation. If we
Mm.
go to the next part, which is like two standard deviations, here these are the people who are above expectations. So this will be another 15 percentage. So above expectations are the people who have really done a great job, or the managers are really liking them and kind of, and they are able to do the things what is assigned. Or additionally, they
Mm.
are able to do certain things which are beyond expectations also. So they are people who are doing that, right? And
Okay.
there will be another 10 percentage from here. This group is the one like they are top of the top performers, right? So they'll be very key persons in the organizations who have contributed very significantly for the team's growth, and
Okay.
they will be the top performers,
Okay.
right? So
But
if you just add up all these numbers, this will add up to 100%.
100%. Okay.
Right? So this is what
Mm.
what we say is the mean will be 50 percentage, which will be
Mm.
exactly the numbers in terms of percentage, it will be
Mm.
50.
Mm.
But what happens is from the mean, how much the
Mm.
deviation can be there. So that will be
Ah.
within this one standard deviation. That's what we'll be seeing here as well. You can see in our graph also, this will become your one standard deviation,
Mm.
and this becomes your two standard deviation. This will become a one standard deviation. This will become two standard deviation, and slightly as this curve goes like this, and this becomes three standard deviations across, right? And same way
Mm.
here also, this will become your one standard deviation, and slightly here, this will end, and that becomes your 2 and 3 standard deviations. So basically, this part will be your mean value. So what is your mean value? Mean will be your center point. So ideally,
Mm.
we call it in statistical terms, this mean has to be like 1. 1 will be the value because it will start from 0. Mean will be
Mm.
1, and likewise this
Then,
goes on.
okay. No, if there are like 10, then one cannot be mean, right?
Sorry, if there are 10,
See, 0, 1, 2, 3, 4, 10. Only if
ah,
it is like half, exactly at the 50th percentile is mean.
yes, yes.
Mm. Okay.
So yeah, no, you are right. You are right, Deepa. So exactly the 50th percentage will be kind of like half of that will be a mean. Yeah,
Mm.
right.
Mm.
But why we are saying this as to be a 0 is basically 0 or 1 basically is to say, like, in terms of statistically what we'll do is we'll not take the values as it is, right? So we'll be transforming the values. So I told you about the transformation. For example, if people's height is there or salary is there, assume. So some individuals will be taking 1,000 rupees. Some individuals will be taking 50,000. Some will be taking 5 lakhs. Some will be taking 10 lakhs, 50 lakhs, right? So if you now try to represent all these data points under one single comparison, basically what happens is your particular bell curve will be too much, right? So you will not be able to represent this data with which will have a very large variation. So in
Mm.
order to avoid this, what we do is we basically compute a mean zero value, which will basically tell we'll be taking the maximum minus minimum divided by the maximum. So I think I did show you this example. If a salary is 1,000, so 1,000 minus
Max.
100,000 or 10 lakh divided by 10 lakh. So which
Mm.
will make this 1,000 as 0.0001 kind of like that,
Mm.
right? And
Okay.
similarly for other values, like people who are earning 50,000, it will become zero point 0.5 or 0.05,
0.5, yeah.
right? So similarly, it will rearrange all these numbers between 0 and 1. Right?
Mm.
So here what we are saying is once you have transformed this data and then trying to put that in a form of a bell curve, the center point here will be zero point 0.5, where it will be the center will be 0.5, and to that 0.5 is what most of my values will be ranging. Either it will be on towards my left or right, or one
Mm.
standard deviation or two standard deviation. The most of my values will be able to fit across.
Mm.
Right, Deepa, you are getting this concept of
Yeah, yeah, yeah.
normal distribution.
Yeah, yeah. It should be max minus min by max.
Exactly. So that's how we do a transformation. So not on all scenarios we do the same approach, right? In this is one
Mm.
scenario we
Scenario.
do in this kind of. In some cases, what we also do is we take a square root. So
Okay.
square root of 10 lakhs, square root of
Uh-huh.
10,000, square root of 1,000. So that also brings down the value for us, right? So
Okay.
that in
Yes.
that way also we can reduce the numbers and the variations we'll be able to reduce. Or in some cases, we also take a logarithmic values. So log you might have heard about. So log of a particular number, basically 2 log of log 2 to the base something we'll be giving. So generally what happens in this scenario also, the numbers whatever we'll be entering will become lesser in value so that it is more comparable it becomes,
Mm.
right? So this is also other kinds of transformations, but we will be seeing those kind of transformation as we are going to work in our real-time problems, Deepa. But for now, for you to get a grab of this normal distribution, this is
Mm.
something that when the mean there are three measures that we generally take. One is mean, median, and mode. Okay, so I'll show you some examples on when to use what and why one is more effective than others always. Right. So this is a very important interview perspective question as well. So here we need to make sure that in order to find any data patterns, before finding any data pattern, you always find what is a mean, what is a median, what is a mode, and then only you try to start looking this information
Hmm.
further. Okay, so now we saw the concept of normal distribution. So this can
Hmm.
also be applied in a real-time scenarios, as we in our organization also follows this approach only. So when managers are trying to say like, okay, I'll give you, especially in India, I'm not sure in US how it is. If it is an Indian manager, they generally say like, okay, I'll try next time. I'll try my level best to give you something, and they just make the employee keep on
Mhm.
working, right?
Right.
But the employee doesn't know that this works on a basis of normal distribution only. So he can only give to my top one
Yes.
percentage of rating, 10
Hmm.
percentage my above expectations, and rest all he can give only the medium rating.
Meets expectations. And also,
Yes, the
even
meets
they
expectations.
have to give at least one hour that percentage and for serious underperformance also.
Yes. They have to actually. So generally, what they
Already.
do is they generally give that rating for people who are moving out or who
Hmm.
are likely to move, kind of, and then they assign that rating actually. But in a team, below expectations means every year, then the expectation has to change, right? So that is the only way in which things can work. Because if the expectations are going to be same, it will be difficult for us to rate people below expectations because most of them would have known that, right? So
Okay.
when the expectation changes every year, then I think this makes things different. Okay, fine then. So now let's look into our data points, what we will be using this for, kind of. So let's, for an example, I think something got played from here. Okay. Uh, okay. So now let's take some data points and we'll try to put the data points and try to find the mean, median, mode, and kind of. So for which I'm going to declare data points here. So let's declare 50, 190, 170. So let's take the height of people, right? So 170, 180, and this, let's make it as 150 and 200, 210. So all in centimeters, right? So all in centimeters we are taking. So, and 165, 155, 60. This is a set of heights of few people I have considered, right? So here what I'm going to do is I'll first import NumPy because I'll be using NumPy for all my calculations here. So NumPy as NP import and okay. So I'm just importing these data pointers. Okay. So now I wanted to um, find basically a mean of this particular data. Okay. So how you think I can find a mean of this data?
Can we write that formula first, find out the max and then min, or it will have built in
Yeah, we'll have built-in
random
functions.
random dot mean do we have?
No, we don't have a random dot mean. So basically, in order to find,
Mm.
we basically use in there is a module called statistics. There is a module, but
Mm-hmm.
in NumPy, how are we going to look into the mean values is something called numpy.mean we have. Okay, so
Mm.
whenever we are creating an array, so we basically need to create it as a NumPy array, and then we can basically compute the mean. Okay, so here I'm going to create this particular data point as a array. So data equal to np dot array of, I'll be entering all this data points inside this. Okay, now this data becomes a NumPy array. And after I create this NumPy array, I'll be able to use the mean and median and the other functions. So, okay, so np dot mean, there is a function, np dot mean of data. So basically what happens is this basically gives me what will be the mean value of this. Okay, the first time I think it takes a while to load. Yes, it is giving me an error. Let's
Mm.
decode what this error is. Okay, module NumPy has no attribute ARR. So what is the mistake here, Deepa?
Only Y extra, right?
No.
No.
AR NP dot. So how do we give in NumPy declaration?
Yesterday
ARR
always.
AY, right?
Hmm.
Right?
Okay.
So, so it
Dot
has to
me.
be NP dot array, ARR AY. Right?
Okay.
So that's why it was not able to recognize there is a module called NumPy.
Hmm.
Hence, this was giving me an error.
Hmm.
Okay. So now we have computed the mean.
Hmm.
Okay. So now the mean is how much, what is the mean height of this particular group? If someone is asking, we can say it is mean height is 175 centimeters
Hmm.
across. Okay. So now what I'm going to do is I'm going to introduce different values like 500,
Hmm.
600, 1000,
Hmm.
right? So
Hmm.
now you see what is going to happen for the mean.
Okay.
The mean
But which
is
is not
get,
right.
yeah, exactly. This is not right in our statistical terms or in whenever mathematically this is fine. But on a
Hmm.
real time basis, when you are going to see this data, assume there are 10 million data points like this.
Hmm.
You are trying to compute the mean of all these data points and trying to see like how closer or far away the data is, or what is the spread of this data you are trying to understand.
So,
So what happens here is this
can you
basically,
print that graph? I mean that bell curve graph, because
yeah,
150
yeah,
is least, 1000 is bigger. Rest all it is not in sync. Hmm.
yes, yes. No, we are going to see that bell curve shortly
Okay.
because for bell curve, before that, I'll make this concept clear for you.
Mm-mm.
So, and next will be, we are anyway going to put it across in a bell curve. Okay.
Okay.
So just keep this in mind. Mean is something which is always affected by outliers.
Hmm.
Okay. Mean is the one which always gets affected by outliers. So these are the outliers that we are talking about. But in case where there are issues like this, so how are we supposed to handle this? Okay. So for this only, what we'll generally use is we already have the data now. So we will use something called median. Okay. So what this median basically does is instead of mean, which takes all the values and divides it by the number of observations,
Hmm.
median works in a slightly different manner. It takes all the values but
Hmm.
it tries to divide the numbers. So, for example, how many records are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
11.
Right? So, what will be my median now? Median is nothing but my center value, center point.
Hmm.
So, for this particular data, what will be my center point? So first it needs to be sorted. Okay, it needs to be sorted in ascending or a descending order.
Okay.
So it
Hmm.
first sorts it and then it tries to find the center point of this data. So assume you are sorting it from lowest till the maximum,
Hmm.
right? And now what it does, it basically tries to find what is my center point. You see, it is
Hmm.
saying my center point is 185. The reason for that is it has sorted it. It has taken
Hmm.
totally 12 records. It
Hmm.
basically, after doing the sorting, it takes
Hmm.
sixth and seventh record and
Okay.
divides it by 2.
Okay. Suppose if it is 13 also, then 7th and 8th,
Where 13? Yeah,
number
no,
of values.
if it is 12, it just takes sixth and seventh. Sorry,
Hmm.
sixth and seventh it takes. If
Hmm.
it is 13, it takes seventh record.
Okay. 7th and 8th or
No,
equal
only seventh.
distribution.
In
Okay.
odd numbers, it is easy to find out the center point. The
Okay.
issue
Hmm.
is in even numbers only, right? Because
Okay.
the even numbers will be having two even numbers. So getting a center point will be difficult. So what it does is, for example, if there are 8 numbers, it takes fourth and fifth and divides it by
Hmm.
2.
Hmm.
Similarly, if it is 12 observation, it takes sixth and 7, divides it by 2. But
Hmm.
if it is 13 observation, it just takes the seventh observation, seventh record. Okay, so that's what happens with median. Okay, and there is also another concept here which
Hmm.
helps us to work with categorical data. So
Okay.
I'm going to say data1 equal to np dot array of. So here, what I'm going to do, let me give some categorical records like male, female, like this. Okay. So I'm just giving a set of records here, data1 equal to np dot array of. Here, basically, we are going to see a concept called mode, Deepa. So mode is a concept which is not directly available in or NumPy. So we'll have
Hmm.
to import a particular module called SciPy, scientific Python, this is called as.
Okay.
So I'm
Hmm.
going to import a particular module called SciPy. And from the SciPy, I'm basically going to say, I want to compute the mode of this data. Okay. So the same as we created this. So when you are going to work with categorical data, you
Hmm.
cannot just compute the mean or median because mean and median works mostly for the numerical data only. For
Okay.
categorical, mean and median will not work, right? So in that scenario, what you do is you make use of something called mode. So this mode is a concept that will be really helpful here. Now let's see. So what this mode says, do you have some idea about mode, what it does?
I only remember the terms mean median mode, but no concept behind it.
Yeah, okay, no worries. See, mode is nothing but which is the data which is occurring maximum. Okay, so I'll tell you some real-time
More number
examples,
of
right? So
times
when,
which is repeated.
yeah, which record is getting repeated more number of times. So in a real-time data, what we do is assume you are trying to do a credit card prediction, or you are trying to predict the person who is going to buy insurance or not. So in these kind of scenarios, what happens is you will be taking a gender parameter.
Hmm.
So in a gender parameter, most of the records will be there, but there will be some missing records also, where the gender itself is missing, like male, female, and this gender might be missing in some cases.
Yeah.
Right. So now what happens is whenever there is a gender difference or things are like this and there is a missing value, we generally replace the missing value with the mode of that record. So, for example, if there are few records where there are two populations, male and female, are there. So, female, there was few records which was missing. So, what we generally do, we generally replace that particular value with the missing value there, which is basically the gender. We replace it with female or we replace it with male, depending upon which value has been maximum reoccurring in that data set. Okay. So here also we are going to do, just going to find it out. Okay. So here, which value is reoccurring more?
Mm. 1, 2, 3. No, it is equal.
It's
Not
equal.
more. I mean, both are equal.
Okay. That's interesting. Let's see what it is giving. Okay. What it is saying.
Not recognized as numeric. You give string values. Cannot be create coerced to numeric array.
Stats dot mode is not available. Hmm. Stats dot mode is not there. Okay.
Maybe numbers we need to change.
Yeah, let me check. So it was not able to find out previously. No, looks like stats.mode is no more available for deprecated in Python 1.9 and removed in SciPy. Please consider np.unique.
Dot unique.
Okay.
Okay.
Yeah, let's consider
Deprecated means it is no longer available, right?
it is removed. Actually, earlier this was there, so they have
Mm.
removed it in this version of Python. As I told you, Deepa, what happens is these people keep on reinventing things
Mhm.
across. So
Suppose if
the
somebody has
version,
written all the code and they are currently in that version, if they are
yeah,
doing some upgrade, so they have to
yeah.
go check manually and change wherever it is there, or it will automatically get updated.
No, mostly it will be the backward support would be available. But what they would be doing in these cases is maybe since this mode was something which was no more used, kind of, I think that's why they had to remove this. So, 1 minute, I think before that, did I import SciPy? I think I have not imported scientific Python itself. Maybe that should
Be
be the
hint, right?
reason also. Import, you see, now this is coming. SciPy as SP and yeah, sp.stats.mode. So two ways we can access this. Deepa, let me just take this data. I'll put it across. See, that's the reason I'm not coming with a pre-prepared code because you should also know what are the errors that we are getting. So it will be easy for you to debug and rerun the errors again along with me. So when you are running it individually, it will be better for you. Okay. Now let's see. I think this should work. You see what is that output that it has given? I think I have taken as data. So it has given me a value of 150. Let's take this and try to find it. You see, yeah, this is no more available for categorical variables. So that's why it is not working for data one. You see here, this works for
String.
our previous data, which is numerical in nature. But
Mm.
for categorical, we are supposed to use something called np.unique only. So here, which is the value that is more reoccurring? It is saying 150 is the one which is reoccurring more, which is
There is
one
no
time.
repetition at all. Okay. 150,
Yeah,
155. That's all.
yeah. So that's what it is saying, and it is saying mostly the reoccurrence is here only. So let me insert some reoccurrence. Let me say 190, 160, 1. Okay. Now let's see which is the value it is giving. I'll first recreate this, and it is saying 160. So
Mm.
160 is getting repeated once, twice, and maximum only two
That's all.
times.
Only two times.
Yeah, okay.
So
Okay.
in the bracket 2, it is showing is 2 times it is repeated.
Exactly. That's what it is showing. The count np.int 64. This is saying the count is 2 times. So the value that has occurred is basically the mode, which is 106.
Hmm.
Okay. And now since this was not working, let's look into unique also. Okay. So here will not be np.unique dimension, right? np.unique of data one. Okay, let's see now. We'll be printing the unique and the mode both. So unique basically here, see, since both of them has got equally repeated here, my unique value has given both male and female,
Okay.
because there is a reoccurrence of male and female equally. So now let's do one additional record. Let's just add female again.
Comma is missing. Okay.
Yeah, here, 1 minute. Here, what has happened? Uh, Bracket is more. It's also more. Yeah. Okay, now let's see. Now it is still saying female and male. Okay.
How
So
did the error
unique.
go all of
Okay.
a sudden?
Sorry. No, no, no. I was not using mode there. So what I was using
Oh,
is I
okay.
was
Yeah.
just
That's why
using
you added
unique.
extra. Okay.
So that's why it was basically saying only two unique records were there, right? So, and it was trying to say like this is that value. Basically, it is taking unique records only here. So when there are unique records, it is saying there are two unique records. One is female and the other one is a male. Are you getting this concept, Deepa?
No, but result I can't understand because everything is same. It is showing both.
No, here there is a difference between mode and unique. So this is not one and the same. Basically, what it has
Hmm.
done is in a mode, what it does, it takes only the maximum reoccurring value. Right. So here, what they have done is in the recent stats module, they have basically removed this concept of mode there. Okay.
Right.
So
So
when once
data
so we
one
were trying,
find
yeah,
finding mode of data one is not possible because it has string
yes,
values.
yes, exactly. So whenever we are going to have categorical data, right? So
Hmm.
when we are going to have a categorical data, which is mostly like our this values, male, female, and these things, we'll
Hmm.
not be able to use mode there directly. So basically what we might have to do is we might have to find it in a slightly a different way.
Hmm.
Okay, let's try doing that. So the unique basically is going to give us only the unique records. If there are like 10,000 records and you wanted to know how many unique values are present, we do a select distinct, right, in a SQL. That's how this unique works. But let's try to compute mode of this particular data. Okay. So since there is nothing called mode, which is there, so let me say mode data equal to. So I will say uh, this particular data set is what data one. Okay, data one dot. Let me see if there is a function that is available. Yes, it is there. There is a function called mode is available. Let me try using this. Uh, no attribute mode. Okay. Did I use it the right way? Is there a syntax error? Okay, so I have created it as a numpy array first. Let me verify. Okay, I have created it as a numpy array. Okay, so in this numpy array, I am creating it as values itself. Okay. Okay. Let me do one thing. I'm going to convert it as a dictionary, Deepa. Okay. Let's
Mm-hmm.
see how we can try to, because I need a field name to be mentioned. So I'm saying gender. Okay.
Mm.
So I'll say this as a gender and I'll insert all the records into this
Okay.
male, female like this. And now let's try this. So here I'm creating an array. What is do we have a closing bracket? Yes. So it is showing an error. Okay. I don't need to declare it as a numpy because it will be a dictionary object. So I'll be directly creating it. So for a dictionary object, I need to use curly braces. So I'll be closing it with this. Now is this fine? I think this is okay now. So let me remove this unique statements and all. Okay, so let's create a new data with a dictionary object because the previous one seems to not work because this mode was not accepting directly from a NumPy. These guys have removed this concept of mode there, so I will not be directly be able to use this. Okay, so now what we'll do is we'll try to find out a mode of this particular record. So here, when going to give this mode, I basically need to um, import one more module. Okay, so I cannot directly use this. So let's do one thing. Let's import. I have not introduced you to pandas yet, but for this particular exercise, I'm just saying pandas is also a kind of similar to NumPy, but this is used mostly for what kind of objects is it is mostly used
Okay.
for creating some structured data across either the
Okay.
database connections and these things. We generally use pandas object there, right? So now what I'm going to do is I have imported this PD and I have created the data set. So now what I'll do is let me say df equal to pd dot data frame. Okay. So now what I'm going to say is I'm going to take this particular data frame and I'm going to convert it as a data frame. So data frame is nothing but like rows and columns. How do we have it in our database? So this
Mm.
basically takes the dictionary object and it converts this dictionary object into a data frame. Okay, so that's what this is doing. So now what we'll do, I'm not going to do a unique here because I wanted to see mode. So I'll be taking the mode of this data. So here, mode of, I cannot directly say dot here. This will be, I created a data frame. So I'll be saying df of gender. And then I'll say dot mode. Okay. See, just to revisit this concept again, Deepa, since the earlier we used to have directly a mode concept in our stats module itself in Cycle,
Okay.
right?
Mm.
So these guys have removed that latest in the latest module. Here currently, since we are using Google Colab, this
Mm.
uses latest version of Python, right? So the previously this used to work, but now since they have removed it, what we are doing is we'll create this particular value as convert this value as a data frame. So what is this data frame? Data frame is nothing but like our SQL. In SQL, we have rows and columns, right? So basically we'll be having n number of columns and these many number of rows. It also does a very similar thing. It converts this particular dictionary object as rows and columns. So row wise, it will be gender would be given and a male and female and these things will be given for the values of this gender, right? So now when I'm
Mm.
trying to find the mode of this, you see, It is displaying the mode is female.
1, 2, 3, 4, 5, 6. Okay, one is
Yeah,
extra.
right. So now we are able to find directly the mode of this. So slightly what happens is, Deepa, and as we are seeing in this real-time
Zero
case, right?
means
So
it is not
yeah.
position, right? What is zero here?
It's not the position. No, it is not the position. It's basically what it does is zero is nothing but, so since I didn't introduce you to pandas, the zero is nothing but the axis. So
Mm-hmm.
we call zero will be the first axis, one will be the second axis. So since I didn't talk more about that, it is just displaying an axis. So for now, understand this as an axis level. So zero axis, one axis, likewise, they will be indexing it in pandas. But I'll show you when I'm introducing you to pandas. But for now, consider zero as axis only.
Mm-hmm.
Okay, and gender here will be the object that I'm trying to refer. Okay, are you getting this concept, Deepa? Right, so slightly we were trying to work it out with mode, but
Mm-hmm.
I got to know also they have removed this mode as a concept from NumPy, so we'll try to use pandas and try recreating it. Okay, so now since we know about mean, median, mode, and we'll also see one more concept now, which is called the standard deviation.
Mm-hmm.
We have not seen the standard deviation as a concept yet, but let's see that now. So for the data, whatever we were having above, so standard deviation is what is basically, as we saw on this graph. Let me recreate a new one. As we saw on this graph, Deepa, there will be x-axis, y-axis is here, and here we are fitting a bell curve, and the bell curve is going this way, and this is the mean of that bell curve, and we are having this mean value here, right? So till here we saw, but what happens is we did see a line till here, right? So how far away a particular value is moving away from the mean, that value we generally call it as a standard deviation. So what we can say is, so why this particular measure is required? This is specifically required in order to see, like, if there are new data points that is coming. So let's take our previous example of the sugar levels itself, right? So the HbA1c of 20 people we have taken, and all this we have tried to plot it in a bell curve, and we are trying to get some values across like this. So now we got the mean. So when we are going to see a new value, what is coming? So assume the new value is 175. What is my mean? My mean is 170. Assume your mean is 170 as per our example. When a new value has come, so we wanted to see, like, how much is this new value has spread away from the mean, right? So basically this will try to give us the spread of the new data also, and also in case you are going to compare different groups, right? So for a first group the mean is 170, for the second group the mean will be 160, right? And there will be a different new value when it is coming, the spread will be even more if there is a new pointer which is coming like 175. So basically this will be, help us to say like how far the data has been moved away from the mean. That is what this standard deviation is all about. So the standard deviation basically has a formula by itself, right? So this is basically helping us to measure the dispersion of the data. So dispersion, what we say is how far away the data is moved away from the mean. This can be also a standard deviation, either on the left or right, or this can be one more standard deviation, and this can be one more standard deviation. So generally, this is standard deviation number one, this is two, and this is three. Generally, what we say is if a particular data point is too much away from here, which is too much away from the mean, which is more than three standard deviations, we call them as outliers, right? So we saw an outlier now, right, in our height example, which is like 500 centimeters, 1000 centimeters and all. So these pointers will be like too much away from the mean. So when a particular point is very much spread away from the mean, that is called as outliers. Okay, so basically these, we generally say the three terms, mean, median, and mode, as measures of central tendency. And this particular measure of standard deviation will help us to tell like how far away this data has been moved away from the mean.
Okay.
Okay, Deepa, you are getting what this mean, median, mode, standard deviation means. Okay, so let's now see
How far
practical
can you repeat how far you are moving away from
mean
me
from the mean. So yeah, yes,
mean?
from the mean. So for
Okay.
example, let's take the same example, right? What is the mean of this? It is 172.5.
Right.
Okay,
Mm.
right. Now what we'll do to the same pointer, let's compute
Mm.
a standard deviation.
Okay.
Okay. So how to do the standard deviation? I'm saying deviation equal to. So there is a formula similar to that with an numpy only. So we
Mm.
are just going to compute a standard deviation of this. So what this says, it takes all the data points, Deepa. Okay, first I'll show you the formula for a standard deviation. Okay, so this is what the formula for a standard deviation looks like. Okay, so this is how it will look like. You're able to
The
see my
E sign
screen, right?
also. What is that E sign? Is it called sigma or I forgot it?
Okay, yeah, I'll tell you. Let the page get loaded. Are you able to see this?
Yeah, yeah.
Okay, okay. Let's as of now use this image only since you are able to clearly see. See, this is
Mm.
basically sigma we say. Sigma is what? This is nothing but a summation of the values, Deepa.
Okay.
So x minus x
Mm.
bar or mu, they say. Mu is nothing but a mean. So what
Mm.
they say here is this value, what we have considered, the first value
Mm.
minus the mean value. So what is the mean? 172.5. So what the standard deviation basically does is it takes the first value and it subtracts it from the mean and it squares that value. Okay.
Mm.
So and it squares that value and divides it by total number of values. So basically what happens? The first value minus the mean. In our example, it will be 150 minus 172.5 plus 190 minus 172.5 plus 170 plus 172 minus 172.5. Likewise, it takes each and every value and tries to subtract it from the mean, and finally it squares that value, and
Okay.
then it takes the square and divides the whole value divided by numbers. So if there are 10 records, I'll be dividing it by 10. But there is n minus 1 also. What they have given is whenever we are going to estimate a sample, so there are 10,000 records. Out of 10,000, we take a sample of 1,000. So in the whenever you are going to take a sample, you have to do the division as n minus 1 instead of n. So that's what the difference between this and this is, population and sample. And then we take a square root of that value. Okay, you see here, this has computed everything. For each and every record, this has computed this value and it has put the standard deviation of this record across. Right? What it is saying basically is from the mean, the distribution of the data here is spread not to that extent. It is just like 17.96 or 18 plus 18. 18 plus mean is what the maximum plus or minus the mean value, the standard deviation is. What we can say here is 172 plus 173 plus 18. So it is saying maximum the value has spread until like 172 plus 18 and then or plus or minus to 18. So there are a few outer values also like 210, 200 is there. But maximum the dispersion or the spread of this data has been from the mean, it is just like plus 18, plus or minus 18.
Hmm.
So that means my distribution here is forming a normal distribution is what it is saying. But unless until we put a normal curve and see, we will not be able to look into this, right? So what we'll do is, as a next pointer, we'll also see how to put this in a normal curve. So because that is going to be our main agenda of learning this mean, median, mode, standard deviations, everything.
Okay.
Right. So for example, if I'm giving an outlier record here for this 500, 600 is there. Now let's see. See, the mean has increased. And now let's see the standard deviation. You see here. So the standard
Hmm.
deviation has jumped from 17 or 18 to 134.
Hmm.
Right. So from this particular measure itself, you can say, okay, there is some issue in the data. So the dispersion of this data is not evenly distributed. There is some issue, what we could observe from this particular data. So this is something clearly it is visible, right?
Can
From here.
you repeat? Because in
Yeah.
mean it was 172.5 earlier.
Yeah. Yes.
What you changed to get 226?
Yes. So why it changed to 226 you want to know?
Hmm.
No, because since I added an outlier, right? The mean is more prone towards outliers. Right? So since I just added two data points, now the mean got
Hmm.
shifted to 226.
Okay, okay.
So it is right. So this is also saying, see, this is one measure. Okay, so from just by seeing mean, you will not be able to understand whether the data is the distribution of
Correct
this
or not?
data. But when you see the
Okay.
standard deviation, it is clearly giving you an indication. It is saying there is some issue in your data because from mean it is like 134, there is a deviation, which means there is
Mean to
some issue.
say
Yeah.
70 to 80 points difference, which is not likely to happen.
Yeah, exactly. It means that there are outliers, right? So are we able to understand something? There is an issue in the data at least. If not, we can understand there are outliers. So by practice, you will be easily able to do that.
Hmm.
So
But for
from as
500,
you practice,
600, it can be. There is so much of gap, right? For 500 and 600 value.
yeah.
So it can be true for that, but not for values from 150 to 170.
Correct, exactly. But see, here for a height, it cannot be like 500 or 600, right? Eh,
Hmm.
we-
Hmm.
So that's why this domain understanding is also required, right?
Okay.
So when we are talking about this data science or these concepts and all previously,
Hmm.
right? If you remember, we were saying
Hmm.
machine doesn't understand anything.
Anything, right?
We are the
Okay.
ones who needs to tell to the machine that this is wrong, kind of, right?
Okay.
So you are the one who will be telling to the machine, okay, this is an issue. There is
So this
something
is
going
where
wrong.
generally first data after the data ingestion, this data cleanup process will happen, I think, right?
Exactly. As a part of this data cleanup and these process is
Mm.
what we'll be doing these steps. Yes,
Mm.
exactly.
Okay, got it.
Yeah. Okay. So
Okay.
now we
So
understood the concept of
to iterate, mean is a exact 50th percentile value. If it
Yes,
is
yes.
even, it should be the sum of mid value plus mid plus 1 by
Yeah.
average of mid and mid plus 1. If it is odd
Yeah,
number,
it's basically the middle two values. Yes.
it is exact straight one middle point.
Yes.
Median is wait, that is median.
So median is the mid value, as you rightly said. Mode is the one which is maximum reoccurring value.
Repetitions. Okay.
Yeah. When we are directly having more number of values, that comes there as mode.
Mm, mm,
Right? So, and this standard deviation is something, right? How
mm,
far the data is deviated from the mean. To estimate
mean
that, we compute the standard deviation.
mm,
Okay, fine, Deepa. So I think before we see a normal distribution, you take a break and
mm,
then you can continue our assignment question
mm.
during the break. Let's take 15, 20 minutes if you want. We'll then catch up again.
Okay.
So I'll keep the assignment question open.
Mm.
So yeah, I think this is this
Then
document.
how can we eliminate the duplicate values? I try to write for loop and dot remove from the
Ah,
list,
hmm,
but
okay. No, you can find it, right? We'll see the answers anyway, but
mm, because I don't
I'm
want to
sure.
Google it and see.
No, no, please Google it and see, because
Okay.
why I'm giving this exercises for you to understand these things, right? So when you are going to work independently, how
Mm,
comfortable you will be. So that is what my main intention of this assignment. So please do
oh,
Google and see. No worries.
oh,
You can. It will give you various methods, but
it's
try
inbuilt.
multiple. Yeah.
Mm,
So I'm just
okay.
keeping the questions open, Deepa. You can take a break
Mm,
and
mm,
then we can come here. So
okay.
now, after you are done with this question, in case you are already done, please move on to NumPy also,
Okay.
because we have completed NumPy yesterday.
Mm,
So you can proceed for NumPy questions as well.
oh,
Yeah, I'll stay on mute and
mm,
you can continue, Deepa.
okay. See you after 20 minutes.
Yes, sure. 1 minute, I think yeah, catch you there. Okay. Deepa, how much you have completed?
The first one.
Okay, great. Did you call me Deepa sometime before? No,
No,
right?
no, 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 no.
Okay, okay. Looks like someone else did. Okay. Shall we begin, or
Yeah,
are
yeah.
you in middle of something?
No, oh, we can go ahead.
Okay, great. Fine. So now we have seen these three concepts of mean, median, mode, variance. Sorry, variance we didn't see. We did see about standard deviation and how to use the standard deviation as a formula by using pandas as well. Okay, so
Mm,
now we are clear with these concepts. Now let's begin our distribution now. Okay,
okay.
so we did had an introduction about the normal distribution, but for the same data set what we have currently used, let's try creating a normal distribution out of this data.
Okay.
Okay, so how are we going to do this normal distribution? So this normal distribution is inbuilt module in NumPy only. So we just need to call it across. So we just need a random alone for this, and we'll be just taking a random normal distribution across. Okay,
Okay.
so in order to display this distribution, we also need some visualization libraries. So
Mm,
we'll be using that libraries there directly as well to represent this data. Okay. So first I'll show you how to display a normal distribution. So basically we'll be using from NumPy, we'll be importing random. Okay. So we'll be importing random into this. And what we'll do is we'll be assigning this just first, let's try to create a random number with a normal distribution. Okay, so I'm just going to say random dot normal. So this, what this random dot normal is going to do is it's basically going to create a set of values which will be more of a normal distribution, so or a Gaussian distribution. So basically what we'll be doing here is we'll try to create an array of size 2 and 3, 2 comma 3, which will be 2 rows 3 columns, and we will
Hmm.
be totally having 6 values in this. So let's see how this data is getting created first. Since I have not mentioned about anything, it is by default taking the values as float, and then it is trying to generate some values. So some values negative, some values positive, and it is trying to basically create 6 values, since I just gave it as 2 comma 3 alone, and rest all I didn't do anything. I just wanted to create a set of normal distributed value of the size 2 comma 3. That is what I basically want.
Hmm.
Right. So in order to create a normal distribution, Deepa, as we saw, we need 3 specific pointers here. What are those pointers? We need the mean, we need the median, sorry, we need the standard deviation, and we also need how many number of records are we going to display. We basically need these 3 parameters. So it is basically called as LOC. LOC is nothing but mean, location of the peak of the bell. So bell curve. So in a bell curve, where is my peak located? So that is called as LOC, right? And next is the scale. Scale is nothing but the standard deviation. So what is the standard deviation of this particular distribution? I would like to know that. So this standard deviation basically helps me to understand how flat the curve is, or is this quite deviated across because of outliers and things. And this will also help me to know like what has my distribution, what kind of distribution is this? Is the skewed distribution or not? So I didn't cover for you what is a skewed distribution, Deepa. So we saw only about normal distribution. But
Hmm.
the skewed distribution is something very similar, but what will happen is the peak will be at first, and then the mean will be here. Okay, the mean value will be here. You see, but the peak will be here. So this kind of distribution is called right-skewed distribution. So we'll be able to see this with the help of standard deviation. That will help us to easily identify the skewness of these curves. So we generally call this as skewed distribution. So this is one kind of skewed distribution, but there could be the other way around also. Whenever your curve will be flat and then the skewness, the peak will be at last, but your mean value will be here. This will be your mean, right? So this is also another kind of distribution. This is called left skewed. This is called left skewed. And the previous one, what we saw is the right skewed distribution.
Okay.
Are you getting this concept, Deepa, of this standard deviation? How this is basically helping us to determine where the skewness of this curve is, basically how dispersed this data is.
Hmm.
That will basically help us to tell like how the
Okay.
peak of my curve is.
So
So
how we
here,
use the dots or points in a bell curve, that is how widespread they are or how close they are in
yes,
a
exactly.
bell
Yes,
curve,
how
right?
closer they are to the mean, or how
Okay.
widely spread they are from the mean. Okay.
That is
So
skewness. What is right
Yeah,
and
this
left?
called right and left skewness is nothing but depending on the peak. If the peak of the curve is on the right, it is left skewed. If the peak
Hmm.
of the curve is on the left, it is right skewed.
Hmm.
So it is just the opposite way.
Okay,
So
okay,
just
okay.
keep that
Got
concept in mind, but we'll
Okay.
be seeing that with some more
With
real-time
examples.
examples.
Okay.
Yes. Okay, fine. Fine, Deepa. So that is with respect to this, right? So now we will construct a normal distribution curve. So as I told you, we need for a normal distribution, we need the random module just for distributing the data. But apart from this, I will need two visualization modules, which is basically my matplotlib dot pyplot as PLT. So this will be one module, and also I need something called cbond, which will also be my visualization module. Okay. So now what are we going to do? We will be trying to fit a normal distribution for a particular pointer and see how the curve is appearing. Okay. So I'm SNS dot, I'm going to use something called distribution plot. So this will be called as dist plot. So for this dist plot, what will be first we'll try to use random. Okay. Random dot normal. And I'm just going to give a size of this variable. So let me construct a matrix shape 4 cross 5. Right. So I'm going to create a distribution plot with a random normal size of, or let me make it simple right first. Let's not take it 2 by 2 matrix. Instead, let's say the size as 1000. Okay. Now what we'll be doing is we'll give the size, and you see there is two other scales it is asking. One is LOC. LOC is what? LOC will be the mean of this data, right? So LOC will basically tell me where is the mean of this data. So I'm saying the mean is going to be 50, and it is also asking me a standard deviation value for this. So let's put the standard deviation as 7 for the moment. So it is the closely distributed data. So I wanted to see a bell curve here. Hence, I'm not dispersing the data to that much. I'm just saying the standard deviation is going to be 7. The mean of this data is going to be 50. Is this clear, Deepa, the syntax for you? How are we basically going to do this?
No, can you repeat?
Sorry, please.
Yeah, can you
You
repeat?
had some. Yeah, yeah, sure. See, as we saw for normal distribution curve, as we were
Hmm.
trying to draw it, it always
Hmm.
needed a mean value and it also needed a standard deviation value. So we are supposed to supply both these values. So assume the mean is here,
Hmm.
mean of this curve is here, and the standard deviation is here. Basically, we'll need to supply where is my peak of this data, which is my mean value, plus how much is
Hmm.
going to be my standard deviation of this data. Those two things I'm supposed to supply. So here
Okay.
for this curve, what I'm saying is I'm going to take 1000 data points. And for
Okay.
these 1000 data points, try to construct a normal distribution curve or try to construct a distribution plot for me first. Okay. I'm
Hmm.
not going to
Hmm.
do a curve now. First, let me at least create a distribution plot. So in this
Hmm.
distribution plot, basically, it's going to be of a size 1000, which is from 0 to 1000, and it is going to basically have the values distributed. From mean will
Hmm.
be 50 and a standard deviation of 7. Okay, now let's see how this plot is getting distributed. You see here, this is how my normal distribution plot is coming. Right? So what it is saying, where you see my mean value is exactly at 50, where I
Hmm.
wanted this normal distribution pointer to be at.
Hmm.
right? And after this, you see the standard deviation is also, we will not be able to see the standard deviation, but standard deviation basically tells us how closely or the points are distributed. You see, most of them are very closely associated to each other. So that's why there is no gaps between these bars itself. You see, in a distribution plot, it has evenly constructed this. And there is a curve also, what has come out, and it has
Hmm.
basically a bar graphs are there, and then on top of the bar graphs a normal distribution has been constructed for us,
Okay.
right? So
Hmm.
are you getting this, Deepa, how this curve is looking like, and how is the
Yes.
density? So on left hand
Hmm.
side you see the density on y axis, and the basically the bars represented on the x axis. Y axis we have density, the bars
Hmm.
is representing my distribution values basically.
Okay. Okay.
Okay, so using this we did arrive at a distribution plot.
Hmm.
Yeah, but what we'll do is, I do not want to give at times my mean and standard deviation value and all, because every now and then I cannot um, do this. So what I'll be doing is, see, they are planning to deprecate this distribution plot also next. So they are going to replace it with his plot, and that is what they are saying will be removed
Hmm.
in Seaborn version 14 onwards. You see,
Okay.
that's why this particular module is kind of like ever evolving, Deepa. Unlike our other programming languages where the same thing will be there across. If they find there are some issues or things are not working good here, there are better ways to represent, immediately they'll change this view, or they'll deprecate some of the older versions and replace it with something more better for us to look into. Okay,
Okay.
so now let's come to our point on how to generate a normal distribution plot without using any of my parameters such as mean and standard deviation, or if I don't know that, right? So now you know what is mean, what is standard deviation, but there will be people who are not having an understanding about that. So how they can generate a normal distribution plot, right? So for that purpose, what we'll use is we'll just create a random normal with a size of 1000 alone, and I'll not mention any of these parameters here. Okay. Instead of this, what I'll do is I'll just say a parameter called kind, and I'll mention as KDE. So what is this KDE? KDE is nothing but a kernel density equation. Okay. So what this KDE is used for, and how this is useful. So this kernel density estimation is a statistical method. Basically, what it basically does is to estimate and visualize the probability distribution of data sets. It is basically going to help us visualize the probability distribution of this data set. So this KD environment basically provides very good functionality for machine learning, for financial and crime risk mapping, and all this KD analysis is useful, right? But for now, you can understand this KD is going to estimate and visualize our underlying probability density values. So you see, we are basically representing a density of this curve. And that's why we are making use of something called kernel density estimation. So this will be an alternate to that of an histogram kind of. So, but we'll understand this about this KDE functionality later. For now, you understand that KDE is basically going to generate me a normal distribution curve. Okay, let's see how this is generating a normal distribution curve. Okay, unexpected argument. kind. Okay. I think there is a mistake which was done here. Can you tell me what the mistake is, Deep?
Number random state type. Oh, yeah, type error,
Yes.
normal.
No, it is just a bracket error.
Okay, you didn't close,
Basically,
yeah, parenthesis, right,
yeah, yeah. So
parenthesis.
this has to be for a random, and kind has to be for a distribution plot, right? So I just gave the brackets wrong. So this basically does not have an argument of SNS dot this plot. I think maybe let me give this again and see. Ideally, this should come. Okay, kind equal to KDE. Let's try this. Okay, this plot got maybe they have deprecated this also. Mm, KDE equal to true, I think. Okay, the parameter is no more. This, I think this is going to be as this plot the data KD equal to true. So earlier versions were having this kind of argument. I think now they have changed this. This will be mentioned as KD equal to true from this. Okay. So the previous version was kind equal to KDE. Okay. Now you see the distribution plot has come out. You see, basically, this is constructing my distribution plot, Deepa. So earlier, the syntax used to be kind equal to KDE, but now in the latest versions and things, since it gets updated now and then, they have removed certain data points. So always it is just note this down. It is no more KD kind. It is KDE equal to true. Okay, so the previous thing may not work here. Actually, to be frank, I did use this KDE equal to true in the, sorry, kind equal to KDE in the weekday batch. Like it was, should be not even a week's time. Now they have
Hmm.
actually updated this. If you see in my weekday code, this would be there, but they have updated this now. So this is what it does. It basically creates a density function, and then it tries to distribute a normal distribution. You see here, where is my mean, Deepa, for a normal distribution? You see, it is exactly at 0. And this is
Okay.
1 standard deviation. This is 2
Hmm.
standard deviation. And this is 3 standard deviation. After
Hmm.
this 3 standard deviation, do you see that there are outliers? Same in the case of negative sign as well. Less than minus 3 standard deviation, it's all outliers.
Hmm.
So this is how a perfect normal distribution will look like. Okay. So that for that reason only we were trying this out. But now what we'll do is let's try to put a
Wait,
normal distribution for
um,
our day.
what changed in between these two?
Between which this graph and our graph, the
Ah,
previous one.
hmm.
Okay.
Hmm.
Yes. See, in our graph, you see the mean value is 50,
Which
right?
is exact
And
center point where it is showing as
yeah, that's
zero.
the center point. Because why it came as 50? Because we
Okay.
wanted the mean as 50.
Hmm.
And the standard deviation, what did we give? We gave it as 7. So this was trying to loosely couple all this. Since I
Hmm.
can also change this, maybe assume I'm going to give it as 70. Right? Now let's see. Slightly there could be some variation. You see, it is not exactly. The mean has now changed. Do you see this? The mean value I wanted as 50 is here, right? But the data is now like loosely spread. So the more variation are you able to see between this
Hmm.
graph when I'm having the standard deviation as 7 versus standard deviation as 70. You see, just let's take both these graphs. Okay, this is my graph one. I'll take a screenshot of this to see the perfect difference. Let me put this in MS Paint. Okay, let's do this way. And let's now change the standard deviation of this to from 7 to 70. Okay, now you see this? There is
Mm.
a clear difference in terms of how the data is getting distributed there. So basically, the standard deviation is a parameter which will help you to say how the spread of your data is.
Data. Okay.
Though both of them are one and the same, with the same mean
Mm.
only, but you see here the distribution of these pointers, the graphs, how they are looking across,
Okay.
right? And the third one that we have generated is a perfect normal distribution, which is basically using the default parameters only we have generated. This is even perfect, you can see that. So exactly the mean is at 0 and it is touching all the pointers. The data is loosely coupled. It tells you clearly where is your first standard
Mm.
deviation, second standard deviation, the third standard deviation, etc.
Mm.
Right. So this is the other methods of generating a normal distribution across. So we saw about a usual way. Then we saw how to manually mention the values of standard deviation and mean and then
Mm.
regenerate it. And we also saw by changing these values across. Okay, so this is two, three ways of getting the same normal distribution plot across. Right. So now instead of this normal value, shall we use our data or data and try to
Height.
distribute this?
Mm.
Let's see what has happened. You see, our data is here. So basically,
Mm.
depending on our data, see, let's first display what is inside our
Mm.
data.
Yeah.
Then let's see how this is distributed. Print.
It's actually starting from 200 height.
Yeah, actually, it
It
is.
is.
See, our data is starting from 150. Okay.
Yeah.
So it is starting from 150, but the bars are starting only from 200 onwards because you see, this is the distribution that is required. You
Mm.
see where our data is spread across. You see, from here, our mean is somewhere here, which is 170, right? Our mean is here, mean should be here actually. Wherever the peak is there only the mean has to be. But you see, it is too much skewed. So
Mm.
ours is a right skewed this data point. Deepak, what we have created is. You see here, that though the data is starting, you focus on the line alone, this curved line alone, not on the
Mm.
bars for now.
Mm.
So
Mm.
what it is saying is, though these curved lines are here, there are few pointers here like that 150,
150,
150,
170.
150, 160, 170 is here
Right.
and it is
Mm.
slowly going. But my peak of this data is exactly here in this
Mm.
area. Here is where my
Okay.
mean should lie, where I'm
Mm.
assuming this to be as 172 or something like this. This is where my
Mm.
peak is there. And then my
Mm.
200 comes and there are
Mm.
few data that are distributed in 200 and after that it is like here.
Mm.
So there is a difference, right, between these three graphs. When you are just trying to understand from a graphical point of view, visually, you will be able to see a clear difference between this graph versus our graph, what we have generated. You can clearly say, okay, this particular graph is having skewed data for which the data is getting distributed not evenly. there are issues with this particular data.
Hmm.
Right. So this is where this normal distribution and these concepts are really helpful for us, Deepa, because what it will do is this will help us to understand the underlying pattern within the data. And it will clearly tell whether your data is evenly distributed or not. See, now we just took only 10 data points. What if there are 100,000 records?
Right, right.
Without,
Mm. Because these are
without
150,
using,
200 numbers, we know which is less, which is more, an average.
yes, yes,
The
yes,
number
yes.
values are
There
two
we'll
digit
not be able
only
to estimate only. There will not be
estimate
able to
only. Yeah.
estimate only.
We don't even
So
able to
this is,
understand.
yeah, exactly why this is there. See, that's the difference, right? So now what is happening is everyone are learning data science without knowing all these concepts only. They are just going ahead, as you rightly mentioned, trying to learn, okay, what is the concept? Without having an understanding on statistics, they are just going, jumping into machine learning, trying to work on problems and trying to prove things. But what really happens is you will not be able to solve real-time problems with that. So you will get stuck. If not here, somewhere or the other, you will get stuck in between. You don't know what the issue is. You don't know why there is a difference is coming and what has happened, right? So all these things to be kept in mind, Deepa.
Okay.
Okay, fine. Are you ready to see one more concept, binomial distribution today, or is this getting overloaded for you?
I am recalling and not trying to remember the definition of standard deviation. That scale equal to 770 you are giving, right?
Scale
Mean,
equal to 700. Yes,
yeah.
yes, yeah,
Mean point
yeah,
straight. Anywhere it will be the midpoint that I remember.
yeah, yes,
Median will be max minus minimum by max.
exactly, exactly.
Okay. Mode is how
No, no,
much of
not max
repetitions.
minus minimum. It is max minus mean. So the current value minus mean. So it will not be max. So
Okay.
median is basically if there
Hmm.
are 10 pointers, this median will be something like here. So what it does is 10, 20, 30,
Hmm.
40, 50, and 60. Okay. So, what is the mean of this records? Assume like the mean of this value is around 50, 60, right? So, should be around 45, assume, right? Just
Hmm.
an assumption, assume the mean is 45. So, how is the standard deviation getting computed is 10 minus 45 divided by the total number of records. How much?
Hmm.
1, 2, 3, 4, 5, 6 divided by 6. And also what it does, it squares this because there could be negative values. So it just squares this and then
Hmm.
divide it by 6, right? And finally, it takes the square root of this particular values. Okay. Are you getting this? So similarly, it will go to the next value, which will be 20 minus 45, the whole square, and
Hmm.
then it divides it by 6, and likewise it goes on and on
We are
till the
calculating that
last.
sigma formula.
Yeah, the sigma is nothing but this, the values from 0, 1 to n,
Hmm. Total.
right? So using that, we
Bottom
just
is
apply, yeah,
capital N, which means total number of which is 6.
number of records it is.
Okay.
Yes,
45 is mean.
yes, 45 is mean.
10 is minimum, right? Minimum minus mean or maximum
No,
minus minimum,
not
right?
not 10 alone. So it takes the first value. So assume this 10
Okay.
to be as x1, right?
Okay,
So
okay.
x1 will be my first value. Here it will be x2. So it is
Okay.
not like our range what it comes, where it takes minimum minus maximum. So it takes
Okay.
this x2, likewise x3, and on and on, xn,
Mhm.
right? So it will be each individual values,
Hmm.
subtracting that individual value from the mean, and then trying to do a square, divide that by 6, total number of records, and take a
Hmm.
square root, right? So when you are just seeing the formula alone there, it is not like it is looking really simple, right? But there is
Hmm.
some complex calculations which is happening in background,
Yep.
right? So for
Not that
each of these,
easy.
yeah,
Hmm. Okay.
exactly, Deepa, right? So that is on the standard deviation. And
Hmm.
then we saw about mean, median, we saw, mode, we saw. Mode is what is the maximum number of values that
Frequency.
are
Repeat.
reoccurring mode.
Yeah.
So that will basically help us to do a mode.
Hmm. Hmm.
And we saw about standard deviation, we saw about a normal distribution, how to distribute the data for any data sets in a normal distribution with using this kernel density option, and how this data points are getting spread across.